languages and the grammar. Okay. So now if we want to summarize this derivation, we can say that language with the help of the grammar, the language which I am making with the help of the grammar can be produced, means the word or the string of that language is always made up of terminals, is always made up of terminals. Star means what? Zero or more occurrences. Zero or more occurrences. So string is made up of zero or more terminals. String is made up of zero or more terminals. And we are starting with the starting symbol. And we are starting with the starting symbol. This starting symbol, we are applying the grammar. On a starting symbol, we are applying the grammar. Grammar is nothing but a production. On the starting symbol, we are applying the grammar number of time, zero or more time, to get the W. To get the W. This is a simple. So whatever the CFG derives, we can write in a simple way. So language of the grammar, which is made up of the words or string, is made up of terminals, zero or more terminals, and we are starting with the starting symbol, applying G, grammar, productions, number of times to get this W. This is what your CFG, the equation of the CFG, equation of the CFG. Okay. So now we see the languages of grammar, languages of grammar. Now we'll just try to write the grammar for the languages. So the givens are the languages. Now we'll try to find out the grammar for that. Finding out the grammar means what? Finding out the productions. From the productions, I can have the variables, I can have the terminals, I can have the starting symbol. So getting the productions are more important. Now the first, we say language is epsilon, A. So any number of A's, any number of A's. So this is the language. So how I can write the production for this? How I can write the production for this? Now S, so starting symbol. So we'll take this S as a starting symbol, not an issue. So S as the starting symbol. Now S can be epsilon first. S can be epsilon. So we'll get this epsilon first alphabet. Now second production, what I can add is A. Second production A. Now any number of A's, any number of A's. So I can write AS. This left hand side variable I am again writing on the right hand side. This is called as a recursion. Left hand side variable, if it comes at the right hand side, it is called as a recursion. Recursion means calling itself. Means the AS, now this S I can again replace with the AS. This S I can replace with the again the AS. So these two productions will give me this language, will give this language. So this again I can write on a single line, S produces AS or epsilon, AS or epsilon. Okay. These two productions I can write like this. So these two productions will generate this language. We'll check with one string, we'll check with one valid string. So if I'm taking this AAA, so I want to generate this AAA with the help of these two productions. So first, always we will start with the starting symbol. We always start with the S, starting symbol. Now this S I can replace with epsilon, or I can replace this S with the AS. So to get this AAA, so which production I will use? I will use this production AS. This production I'm using. So if I'm naming this as a production 1, this is as a production 2. So with the help of the second production, so where S tends to AS. Okay. Now again this S I will replace with the same AS. This S, I will replace with the same AS. So these two I am getting from this AS. Again, one more AS. For this S, I mean having this AAS. Now, for the termination, I will use this second production. So if I am replacing this S with the epsilon, AAA, this production I am replacing with the epsilon. So I will get this AAA string with the help of this two production. So I can get any string belongs to this language with the help of these two production. S tends to AS or S tends to epsilon. So this is the one way. So previously what we are doing for in this language, we are able to draw the DFA, we are able to draw the finite automata, we are able to write the regular expression, and this is the third method we can write in the form of the production. That is nothing but a called as a CFG, context free grammar. Clear? So this is the first language what we are deriving with the help of the productions. Now if we are saying second language, L equal to AAA, like this. Suppose this is the language where the first alphabet A always start with AAA, like this, any number of A's. So the production will be, now here there is no epsilon. So first it will start with the S tends to A. Okay. Next is I want the A number of times. Simple, I can use the recursion. So S I can replace it with A, or this S I can replace with AS. This S again AS. This S again AS. So I will get number of A's recursively. So when I want to terminate, I will terminate with this A. When I want to end that productions, number of A's are over, I will end with this terminal, this production. So where the variable directly produces the terminal. So these two productions will give me this language. Okay. Now the next language, if I am saying third language, if I am saying language is B, AB, AAA, B, like this, end with B, and any number of A's can be there. Your number of A's are 0 times, your number of A's are 1 time, 2 times, 3 times, 4 times. At the end, we'll have the 1B. Now, with this, first I can say S belongs to B, S produces B, because single B I want. So first alphabet is B, so S produces B. Now second production will be A, number of A's. So what is the number of A's? What is the production for generating the number of A's? Number of A's I can generate with this. S produces AS. So we'll get the n number of A's. And when I want to end this last S, I will replace with this B. So I will get a string ending with B. For example, if suppose I am taking this string for generating this string, I am generating. So using sentential form, I can write this. We'll start with the S. No. So now I want the first A. So I will replace it with AS. First starting symbol, I will replace this production. So S produces AS. Again one more AS. Okay. S produces AS. Again one more. AS. SR is a variable, so I will write in a capital letters AS. So again I have used the same production. Now this I want to terminate with the B. So the second A and the B. So this S produces B. This production I use. So I can use this production or this production. So as per my requirement, I will use that production to generate the string. So if that string belongs to that language, then only I can produce that string. Otherwise, no. Okay. So this is what the sentential form for this string, generating this string, and this is the grammar for this language. This is the grammar for this language. From these productions, I can write the V. Variables are the S, only single variable S. Terminals are the A and B, two terminals. Productions are these two productions, and the S is a starting symbol. S is a starting symbol. So for this language, we will have these productions. We'll have this production. So we'll write this production in a single line. So A, S. Okay. Now the third language, next language, if I'm saying A equal to epsilon, AB, AABB, AAABBB, like this, A raised to N, B raised to N. A raised to N, B raised to N. So this is the language. Now what will be the grammar for this? It is starting with the epsilon. So if I am taking the starting symbol as a S, so first symbol will be epsilon. So this will be the first production. This will be the first production to get this language. Now second production will be, I want the A, same number of A's, same number of B's. A raised to N, B raised to N means what? Same number of A's, equal number of A's, equal number of B's. So if I am having one A, I must have the one B. In between, I will write the S again. So this S I can replace with ASB. Again, this S I can replace the ASB. So with the help of this S, I will get the number of A's equal to number of B. So when I want to terminate this, I will use this production epsilon. So this is the second production. This production, two productions will generate this language. We'll take one example. Suppose this double A, double B, AA, BB, 2A, 2B, equal number of A's, equal number of B's. So if I'm taking AA, BB, so sentential form, using sentential form, we'll start with the S, starting symbol. So which production I will use to generate this string? I will use this production, where S tends to ASB. Again, I want this AABB. One more time, I will use the same SBB. So ASB, S will be expanded to ASB with the help of the same production. Now AABB, yes, I don't want this S. So S, I will use the epsilon. I will use this production where S produces epsilon. So at the end we get AABB. Okay. So with the help of these two productions, I can generate any string belong to this. Any string belong to this language. So this is the grammar. This is the grammar for the given language A raised to N, B raised to N. So on a single line, I will use ASB. Okay. Now if I'm just changing this language L equal to, it should start with AB, AA, BB,